Students, welcome to s.mathguru classes. So our main discussion is eigenvalues and eigenvectors. Last videos, some problems are given. It was given. Now we consider remaining problems. Let us consider one problem. Find the eigenvalues and eigenvectors of the matrix A equal to 2 minus 2 3 1 1 1 and 1 3 minus 1. So solution, first you have to find the characteristic equation. The characteristic equation is determinant A minus lambda I equal to 0. This implies 2 minus lambda minus 2 3 1 1 minus lambda 1 1 3 minus 1 minus lambda equal to 0. So we get this. Now we expand this one. If we expand 2 minus lambda, this cancel, this into this into this. So we get 1 minus lambda minus 1 minus lambda minus 3 and minus 2. Then this cancel, 1 into this, 1 into this. So 1 into this means minus 1 minus lambda minus 1. This into this minus 1 into 1 1 plus 3. Then this cancel 3 minus 1 minus lambda. This equal to 0. So we get this one 2 minus lambda. This is minus 1 minus 1 minus lambda plus lambda and this is plus lambda square. We get this. So 1, this is minus 1 minus lambda minus plus and plus lambda square minus 3. We get this plus 2 minus lambda minus 2 minus 1 minus 2 3 minus 1 plus lambda, this equal to 0. So this is 2 minus lambda, this is lambda square, lambda cancel, minus 4, minus 1 minus 3 minus 4, and this is minus 2 lambda and minus 4, and this is 3 into 2 plus lambda equal to 0. Now multiplying by 2 lambda square minus 8 minus lambda cube plus 4 lambda. 2 lambda square minus 8 minus lambda cube plus 4 lambda, and this is 2 lambda minus 4 plus 6 plus 3 lambda, this equal to 0. So this implies minus lambda cube and lambda square, this is lambda square, and we get 2 lambda square and net 4 lambda minus 2 lambda plus 3 lambda, then we get 5 lambda and minus 8, this is minus 4 minus 14 minus plus 6 8 lambda equal to 0. So we get this is 2 lambda square, this and this 2 lambda square, 4 lambda, this is 2 lambda plus 3 lambda 5 lambda, this and this minus 12 8 lambda this is minus 12 plus 6, we get this. Multiplying by minus sign, then we get lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0. So if we multiply by minus sign, we get this. But this is cubic equation and this is difficult to factorize. At that time using factor theorem, let f lambda equal to lambda cube 2 lambda square 5 lambda plus 6 equal to 0. So last term is 6. 6 means 1 into 6 minus 1 into minus 6, 2 into 3 minus 2 into minus 3. If we putting any one of these value, then this must be 0. So we consider this 1. First we putting 1 cube 2 into 1 square 5 into 1 plus 6 1 minus 2 minus 5 plus 6, then this is 0. This is 0 means we get, therefore lambda minus 1 is a factor of f lambda. So this is lambda minus, putting 1 plus 1, then here we write minus. Lambda minus 1 is a factor of f lambda. F lambda 1 is this. So if we divide this by lambda minus 1, we get remainder 0. So we divide this one by lambda minus 1. Our requirement lambda cube, but we have lambda. So putting lambda square, this is lambda cube, this into this lambda cube minus lambda square. So this one minus lambda square minus 5 lambda plus 6. This is plus, this in this, you get minus lambda square. And minus lambda, this and this minus lambda square plus lambda. This is minus 6 lambda plus 6 minus 6 and minus 6 lambda plus 6. We get this. Therefore, what we get? Lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0. This is our dividend. Then dividend equal to divisor into quotient plus remainder. So we can write lambda minus 1 lambda square minus lambda minus 6 equal to 0. So this implies lambda minus 1. This is lambda square 3 lambda plus 2 lambda minus 6 equal to 0. So this is lambda minus 1. Lambda common, lambda minus 3 plus 2 common, lambda minus 3 equal to 0. Lambda minus 1, lambda minus 3, lambda plus 2 equal to 0. So we get lambda equal to 1, lambda equal to 3, lambda equal to minus 2. Therefore, the eigenvalues are, we get, therefore, lambda equal to minus 2, 1 and 3. These are the eigenvalues. Next we have to find eigenvectors. Eigenvectors, from this you can find. Eigenvectors you can write ax, a minus lambda I x equal to 0. So a minus lambda I, we get 2 minus lambda minus 2, 3, 1, 1 minus lambda 1, 1, 3 minus 1 minus lambda, and x we consider x, y, z, and 0 is 0, 0, 0. We get this. And if we multiplying this, this will be, this is 2 minus lambda x minus 2y 3z. In this way we can write 2 minus lambda x minus 2y plus 3z equal to 0. This one. And 1x, 1 minus lambda y, 1z. That means 1x x plus 1 minus lambda y plus z equal to 0. Next 1x, x 3y plus minus 1 minus lambda z equal to 0. This into z equal to 0. So this whole we consider number 1. Now we putting the value of lambda equal to minus 2, 1, 3. Case 1. Let lambda equal to minus 2. Putting lambda equal to minus 2 here. Then 2 minus 2 x minus 2y plus 3z equal to 0. And this is x 1 minus 2y plus z equal to 0. X plus 3y plus minus 1, and this is minus 2 z equal to 0. This implies 4x minus 2y plus 3z equal to 0, and x plus 3y plus z equal to 0, minus plus 3y, x plus 3y and plus z equal to 0. This is plus 2, 2 minus 1, z we get. So this is number 2, this is 3, this is 4 we get. Solving 2 and 3, we get, solving 2 and 3 we get, we solving this, first we consider x, then this cancel, we get minus 2, 3, 1, y, then this cancel, 3, 1, 4, 1, z, this cancel, 4, 1, minus 2, 3. This implies x minus 2 minus 9, y 3 minus 4, z 12 plus 2. So x by minus 11, y by minus 1 and z by 14. This implies x by 11 multiplying by minus sign, 1, z by minus 14. This equal to k1, say. So we get this one, x equal to 11 k1, y equal to 1 k1, z equal to minus 14 k1. Therefore, the eigenvalue we consider capital X1, this is x, y, z, and this equal to x means 11 k1, 1 k1 minus 14 k1, and k1 is common, 11, 1 minus 14. We get, this is the eigenvalue of this. One thing's case 2. In case 2, let lambda equal to 1. So 1 implies we putting in equation number 1, then 2 minus 1 x minus 2y plus 3z equal to 0, x 1 minus 1 y plus z equal to 0, x plus 3y plus minus 1 z equal to 0. That means putting lambda equal to 1. So this implies we get x minus 2y plus 3z equal to 0, x plus 0y plus z equal to 0, x plus 3y minus 2z equal to 0. This is 5, this one 6 and 7. Solving 5 and 6, we get x, this one cancel, minus 2, 0, 3, 1, y, and this one cancel, 3, 1, 1, 1, z, and this one cancel, 1, 1, minus 2, 0. So this implies x by minus 2 minus 0, y by 3 minus 1, z by 0 plus 2. So this implies x by minus 2, y by 2 and z by 2. We get this. So dividing by 2, then we get, if we dividing by 2, then we get x by minus 1, y by 1, z by 1 is equal to k2. Say, we consider k2. That means we dividing by 2, we get this one. So this implies x equal to minus 1 k2, y equal to 1 k2, z equal to 1 k2. Therefore, next eigenvector x2 equal to xyz, and this equal to 1 k2, minus 1 k2, 1 k2, 1 k2. And taking k2 is common, then we get minus 1, 1, 1. We get this is the eigenvector. Next we taking case 3. In case 3, let lambda equal to 3. Next value is 3. So 3 putting here, then 2 minus 3 x minus 2y plus 3z, x plus 1 minus 3y plus z equal to 0, x plus 3y plus minus 1 minus 3 z equal to 0. So ultimately we get this one, minus x minus 2y plus 3z equal to 0. Minus x minus 2y plus 3z. X minus 2y, x minus 2y plus z equal to 0. And x plus 3y minus 4z equal to 0. So this is number 8, 9, 10. Now solving 8 and 9, we get x, then this is cancelled, minus 2 minus 2, 3, 1. Y, then this one cancel, 3, 1, 3, 1, minus 1, 1. Next z, this one cancel, minus 1, 1, minus 2, minus 2. We get this. So next, this implies x by minus 2 plus 6, y by 3 plus 1, z by 2 plus 2. So this implies x by 4, y by 4 and z by 4. Dividing by 4, x by 1, y by 1 and z by 1, this is k3, say. So therefore x equal to 1k3, y equal to 1k3 and z equal to 1k3. Therefore x3 next eigenvectors x, y, z, this is 1k3, 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 and k3 is common, 1, 1, 1. We get this. So these are the eigenvectors. First eigenvector this, second eigenvector this, and third is this. Therefore the required eigenvalues are -2, 1, 3, and eigenvectors are x1 equal to k1, 11, 1 minus 14, x2 equal to k2, k2 is -1, 1, 1, and x3 this equal to k3, and this we get 1, 1, 1. So this is the complete solution of the given problem. So dear students, this solution is very easy, very simple, very interesting also, but most important for exam. So eigenvalues, eigenvectors, this will come in your exam. So I hope you are all enjoying with me. If you are all enjoying, then please share the video to other friends also, then they will get some interest. And if you are getting interest, then please like this video and click the bell icon. Thank you.